Howdy, youngsters. Looking at section 2.5 today, where we're analyzing different functions. We're also looking at piecewise functions, and appropriately enough, it's October. Those piecewise functions are sometimes called Frankenstein. Not sure why I did Dracula there, but oh well, that's what you get. All right, so in these first ones here, we are looking at this particular graph that is looking at speed limits at different mile markers. So on the bottom here are X values, these are the mile markers, and then our Y values are here, the speed limit. And so it's saying what's happening here at the 16 mile mark or this X value. So we just come down here, we see 16, and we follow it up. Now we see that we have an open circle and a closed circle. So we can think of this open circle as an open door. We travel right through it. It's not there. It's letting us know that this speed limit changes at the 16 mile mark. We go from 30 miles an hour, and then it changes to, looks like what? Is that 50, 55? Bingo, 55 miles an hour. And so the next one, we're looking at estimate the miles of highway with the speed limit of 30. So we go to 30 on our Y. We say, okay, I have two sections here. This section, I look at it and I come down here and I'm like, okay, I go from 4 to 8, so it's about halfway, so that's about 6. So about 2 miles there. This one is from 16 and 12, so that's 4. So 4 plus 2 is 6. And then here we're going to be evaluating, so it's giving us what is F at the mile marker of 5, what is my Y value at the mile marker of 9, what is the Y value or speed limit when my X or my mile marker is 14. So I go to 5. Where is 5? I don't know. It's not in the middle. It's a little bit closer to 4. So I follow that up, and I see I hit right here, and that is about at the 35 mile an hour. I go to 9. Where is 9? Not quite in the middle. A little bit closer. I follow it up until I hit something. Bingo bango, and it's 55. Go over to 14. That is in the middle. Head up here. Bingo bango. There we go. That is 30. Now it's asking, where is this thing discontinuous? Or where, if I'm drawing a line, do I have to pick up my pencil or stylus and have to move it? So it's wherever we have an open circle and a closed circle. This is what we call discontinuous. So I have 1 there, 2 there, 3 there, 4 there, and 5. As you can see, we end here. We do not have a solid one here. All right, so I put in those 5 that were happening at 4, 6, 8, 12, and 16. Then it says what happens at each of these discontinuities. That's when our we have a change in our miles per hour or speed limit. So here I'm at 55, and then it changes at this discontinuity to 35. And this next one, we're looking at pool, and this is in thousands. So these numbers over here represent in thousands, as it says there. And this is the time in days. All right, so in this first thing, what is our initial? So that is when we are at 0. So we come up here, that is 46. And what is amount at the end? This is at the end of the 5-day period. So I'm looking at this dot, and the Y value is 28. We don't have to put 28 thousandths because it tells us. When does the amount become constant? So I'm looking at a flat line here. All right, so I have 2 different flat lines. I have it from the X value of 0 to 1. And I have it from 3 to 4. And then once again, we're looking at the X value of 2. And I'm wondering, what is the Y value there? So I go to 2. I travel up. It's a little bit in between 40 and 42. So that would be 41. And then I'm looking at 4. That is here. And I go over. I see 36. And so it's asking us the rate at which it is draining, or it's simply asking us for slope. So my X value is 1. What is my Y value there? 46. That is that point. And then my X value is 3. What is my Y value? Bingo and bank. So I have a point. I subtract my Y's on top, my X is on the bottom. And as you can see, my slope is -5. But since it tells us that we're draining, this is letting us know that it is a negative. So we don't have to put a -5 in there. Here we're looking at these Frankenstein. Still don't know what's going on with that. Anyway, so we have A and B happening here. So just to kind of let you focus, -4, we have to go where it is allowed. So think of this as like the club, certain people with certain types of shoes or dress shirts or, hair or attitudes or money sometimes. Sometimes you can slip a little Benjamin to the bouncer. I guess you guys will learn about this later. Anyway, so we're looking at -4 here. So -4 is indeed less than -1. That tells us that we are plugging it into this function. So I simply plug that in, I multiply. Pretty tough stuff here. Here, where is -1 allowed? Here it is less than or equal to. So once again, it is allowed here. So I plug it into that function and multiply. Where does 0 fit in? 0 is not less than -1. It is greater than. So I'm plugging it in here. Bingo and bango. Where is 2? 2 is greater than -1. So I plug it in here. 2 minus 1. Really rough stuff going on here, people. Next one, more of the same. So we have to find out what x value is this allowed in. So I look at 3, -3. -3 is less than that, so I plug that in. I get 8. -1 is in between -2 and 6. Therefore, I plug that in, and I get +1. I'm looking where I put 1. It is also in between here. I plug that in. I get -1. And where does 7 fit in? 7 is greater than 6. I plug it in here. 5 times 7. Bingo to the bango. Here we're looking at graphs. Once again, we have to focus in on what is happening with particular graphs. Since you're given multiple choice, you can kind of eliminate some of them. POE, process of elimination. So here we can see that this graph is a line. It has positive slope. So those are little things that we can look at. And I'm plugging in values that are less than 2. So to the left of 2. So I'm looking to the left of 2. That has a slope of 0. That has a negative slope. Could be. That has a slope of 0. And that has positive slope. All right, so there's only one graph here on this part of it that has positive slope because it's going up. And then we can look here, y is equal to -1, so I just have a flat line going through -1, and this begins at x at 2. So I'm looking, I have a flat line here. Here, another piecewise function. So we have two lines. One of them has a negative slope, one of them has a positive slope. All right, and so I'm looking at all values that are less than 2. That is a negative slope. And as you can see here, we have a solid or built-in circle. That is because of this or equal to. And then here I have a positive slope with the plus 2x, and I'm looking for values that are greater than 2. So I have an open circle at 2, and I have a positive slope. Here we're looking at these next graphs. We have 3 of them. So we're looking at x values that are less than -4. I also have a positive slope going on there. And we can see that is happening here as well as here. So we have these graphs, that's a negative slope, that is a negative slope. So I'm only worried about 2. In between, I have a negative slope, so it should be going down to the right between -4 and 5. So it's going down here. Also see I have 2 closed circles and have an open circle there because I don't have the equal to. And then here we're looking at a positive slope when x is greater than 5. I have an open circle. I am going up and to the right. And as you can see with this other one, we had a positive slope here. So no bueno. More of the same here. Now I have a parabola that is happening when x is greater than or equal to. So when x is greater than, so I'm looking here, I have an open up parabola. I have a closed circle, so that's the one. And then I have a negative slope here where x is less than 0. Indeed, I do. More of the same here, so I just have flat lines here, 0 slope when y is equal to 2. When it's greater than or equal to 0, that is happening here, closed circle. And then here I have y is -2 when x is less than 0. So I have an open circle, and these are the x is less than 0 values. More the same with 10, except we're also looking at domain and range. So first we find the graph that, we'll find the function that fits. So here we need y is equal to 2 when x is less than or equal to -3. So I have a closed circle here, and my x's are getting smaller there. And then x is greater than 0, my y is -1. I have an open circle, and there we go. What is my domain? So I kind of colored it here. Hopefully that's helpful. So I do need that bracket there because I have a closed circle. And then I need a parenthesis here because of the open circle. And then we're looking at our y values. We only have, even though we have these lines going on forever, this green line only represents the value of -1. And this big yellow line only represents the value of 2. And you see we use braces there. So -2 and 2 are the only y values on that function. More of the same. So we pair up. We have a positive slope here when x is less than or equal to -2. So I have a closed circle. And then I have y equal to 1 as x is greater than -2. Open circle. On we go. And so at this point of discontinuity, it still is there. I can plug in any x value, which is why we have from -infinity to infinity. And then my y values are from -infinity to this y value of -1. Here we go. And this represents only one y value, that is +2. Looking here, all right, so I got a cube root function. So I have this little squiggly line going from left to right. And this is when x is less than 1. Here we have an open circle there. And then I have a positive slope here. X is greater than or equal to, so I need a closed circle. I have it, and on we go. Here, once again, we have discontinuity, but we can plug in every function. If I plugged in x is equal to 1, I do get a y value, so I have all real numbers for my domain. And I have -infinity to this y value, which is -1. I have a open circle, therefore it is a parenthesis. Here I have a closed circle at the y value of 2. And I need a bracket there, and onward to +infinity. On this next one, we have 3 things going on here. Basically, we have the same function, but it's split up between x is less than 7, here in fuchsia, and here in this nice little light blue on top here. And then we just have one value. So y is equal to -3 when x equals 7. So just one dot there. That allows this thing to be continuous or have a domain of -infinity to infinity because we can plug in any x value. And then here, you can see this, green here is included in the fuchsia. So we don't need to have something separate for that. So I kind of put a little green in there with that fuchsia. So we have -infinity up until this y value of 5 right there. And then we also continue at 5. So we see basically our range is all real numbers except +5. And then here we're looking at a step function, which does all y values are whole numbers. All right, so we have this weird looking step function. So whenever we would get a y value that is not a whole number, if we were to cut this, right, we're basically just graphing y is equal to 2x plus 1. As you can see, I'm connecting these solid red dots. And so if we cut that wire here, for all of these in between on the slant that give it a non-whole number, it would fall down to here. So kind of snipping, it falls down. All of these x values produce this whole number here, and then we step back up to this part of the function. So we're eliminating all y values that are not whole numbers.